Bless your heart. Some kind of way you done found yourself for the online tutoring of Mr. Whittington's. Is it Mr. or Mr.? Mr. Whit? How that man say that? Anyway, today's episode is on factories. Now, I don't know what in the Sam here any of this means, but I hope you enjoy yourself, so get your ink pen and your pencil and get ready to learn about factories.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring FBT with a lesson today on factoring using substitution. That's right. There are some times when you're asked to factor that the expression just looks a hot mess, and you're wondering, what do I need to do in order to solve this problem? Well, I'll tell you that there is a method called substitution that can assist you with that process. The bottom line is that you're looking at an expression such as problem number 1, where we have y squared times y plus 1 minus 4y times y plus 1 minus 21 times y plus 1, and you're thinking, what are these y plus 1s and what do I need to do with them? Well, there are two things you should recognize. First of all, in problem number 1, you should recognize how many terms you have. Remember, terms are separated by plus or minus signs. The second thing that you should recognize is that each one of these terms has y plus 1 in common. However, that does not help us simplify the problem just yet. What we will do is use substitution to make this expression much easier to digest. So you can use substitution by replacing y plus 1 with a variable that you make up. So I decided to use x. And when you're using substitution, ladies and gentlemen, documentation is key. You want to tell the reader and yourself when you go back to look at it that you're assigning a variable to this problem that previously did not exist. You're making it up. So you're going to tell the reader that I'm letting x equal to y plus 1. All right, so that's the documentation that's necessary for your instructor and for yourself when you go back to look at your notes later on, that you're practically making this variable up, all right, out of thin air, and you're assigning the value of y plus 1 to that variable. That being the case, you can now rewrite your expression as y squared x minus 4yx minus 21x. All right, this expression looks a lot easier than the expression that we started out with. Remember, they asked us to factor this expression. So one thing we should know about factoring is that you always start with the GCF, the greatest common factor. So I'm going to factor out my GCF of x first. So factoring out x, I'll end up with y squared minus 4y minus 21. All right. Now within the parentheses, you end up with a quadratic trinomial. Well, you can definitely factor that out, especially if you use the process that we show in our video, Factoring Quadratic Trinomials, Part 1. So bring down that GCF of x, open up two sets of parentheses, and I'll be looking at the factors of 21. I know that factors of 21 are 1 times 21, 3 times 7, and basically I need two factors of 21 that will subtract to give me 4. Well, that'll be the 7 and the 3. So I'll start with my variable y in each of my binomials here. I'll have a 7, a 3, and my largest factor will always be the sign of my middle term here in that trinomial. So therefore the 7 is negative. Because I'm subtracting these factors to end up with a value of 4, I need the 3 to be the opposite sign, so therefore the 3 needs to be positive. Now you have your expression factored. However, your variable x was something that you made up. It wasn't part of the original problem. So we have to rewrite this by replacing that original value of y plus 1 in for our variable x that we made up. So my answer will be the quantity of y plus 1 times y minus 7 times y plus 3, and this is the answer to our problem number 1. Let's box it up. Red boxing it. All right, there you have it. That's problem number 1, ladies and gentlemen. On to the next problem. All right. For our problem number 2, we have the quantity of 5c plus 2d squared minus 7 times the quantity of 5c plus 2d plus 12. Unlike our previous problem, we don't have a set of parentheses with a quantity that's the exact same in each and every term. In other words, we don't have a common factor that's identical, something that stands out to us as being the exact same in every single term, because the number of terms here is 3. Remember that terms are separated by plus or minus signs, right? So I only have 1, 2, 3 terms here, okay? However, you should recognize that this expression is quadratic in nature. What I mean by that is that you have a quantity raised to a power that's twice as much as the quantity in the middle term there in your trinomial. First of all, I'm going to let p, this variable that I'm making up, be equivalent to 5c plus 2d. Once I let everyone know that p is going to be equivalent to 5c plus 2d, I can now rewrite the expression. So the expression now becomes p squared minus 7p plus 12. Well, this is definitely a quadratic trinomial at this point. So I'll just go ahead and factor this out like I normally would. So that means I'll be opening up 2 sets of parentheses here. I'll start with my variable p, all right, and then using the factors 4 and 3, I'll go ahead and show that the 4 needs to be negative because our largest factor is always the sign of the middle term here, and since I'm adding to get 7, I need both of these factors to be the exact same sign, so the 3 needs to be negative as well. So that factors that quadratic trinomial. However, that p was something that I made up. The variable p was never part of the original expression. So therefore, I need to plug back in what p stands for, which is the 5c plus 2d. So here, I'll rewrite it as 5c plus 2d minus 4 times the quantity of 5c plus 2d minus 3. And this is going to be the result of our problem number 2. All right, let's go ahead and box it up. That's right. Present your answer gift wrapped. There you have it. That's problem number 2. Let's move on to our next problem, number 3. All right, ladies and gentlemen, in problem number 3, we have 9 times the quantity of x minus y squared times x minus y. Here you'll notice that we have x minus y present in both terms in the expression. So I'm choosing to assign a variable for that x minus y. Also keep in mind, ladies and gentlemen, that substitution is a choice. You don't have to use substitution to solve a problem. It's just a convenient way to do it for most people because it simplifies the way it looks. All right, so right now that number 3 looks a little crazy to me. So this expression will look a lot better than me if I assign the letter n for the value of x minus y. All right, next I'll rewrite our original problem by replacing every x minus y with the variable n. So it looks like this. I'll have 9n minus y squared n. Now that I have the expression rewritten, I can now show that these two terms have n in common. So I'll be factoring out the GCF, the greatest common factor. So factoring out n, I'll be left with 9 minus y squared. Well, this binomial here, that 9 minus y squared, yeah, it's a difference of 2 squares. That means I'll be factoring this difference of 2 squares here while bringing down that variable n. So I'll have n times 3 plus y times 3 minus y. Remember your factoring pattern of your difference of squares. I'll put a note right down at the bottom of the screen here, okay? So now that our expression is factored, and it is fully factored, we still have to replace this variable n that I just made up. The instructor, the textbook, anyone looking at our original problem would not know about this variable n other than the fact that I said that n is equivalent to x minus y. However, n is not in my original expression, so therefore I need to replace that value back in. The value of n is x minus y. So plugging it back in, I'll have the quantity of x minus y times 3 plus y times 3 minus y as my result. And that's the answer for problem number 3. Red boxing it. There it is, ladies and gentlemen. On to problem number 4. All right, getting through these problems today, ladies and gentlemen. Here we go with problem number 4. We have the quantity of y plus 4 squared plus 2x times the quantity of y plus 4 plus x squared. Ladies and gentlemen, we have three terms. This is a trinomial. Remember, terms are separated by plus or minus signs. So my first term here is the y plus 4 squared. The second term is a 2x times y plus 4. And my third term is x squared. This is in the format of a perfect square trinomial. I know this, and I can show this by letting my variable u be equal to y plus 4. Once I let u equal to y plus 4, remember I'm making up this variable u to use, then I can write the expression as u squared plus 2xu plus x squared. This format right here, ladies and gentlemen, I'll show at the bottom of the screen here that that's definitely in the form of a perfect square trinomial. That being the case, I'll go ahead and factor this out now. I'll open up two sets of parentheses. All right, I'll need the square root of the first term, which is going to be u. I'll then need the square root of the last term, which is x, and because the middle term is positive, each x will need to be positive. All right, now if you're wondering if this is going to work out, all you have to do is verify this. You can take the product of your outer terms, u and x, and get a product of xu, and then take the product of your inner terms, x times u, and get another xu term. Combining these xu's, you'll end up with two xu's. So that verifies that this will work out just fine. This will not be the simplified form of your result. However, you can show that this can be combined into the quantity of u plus x squared. Once again, this is our simplified form. However, u was not part of our original problem. Therefore, in order to write your answer, you'll need to replace that u with the y plus 4 that we assigned as that value. So this becomes y plus 4 plus x squared, and this is the answer to problem number 4. Done. Red boxing it. There we go. That's problem number 4, ladies and gentlemen. Let's move on to problem number 5. All right. In problem number 5, we have the quantity of 2m plus n squared minus the quantity of 2m minus n squared. And if you're like me, you've already recognized that this expression is a difference of two squares. That's right. We have a perfect square minus another perfect square. But even though I'm recognizing that this is a difference of two squares, this problem is kind of bulky as far as the perfect squares are concerned. So therefore, I'm going to use substitution to simplify this as much as possible for myself. I'm going to go ahead and assign two variables here. I'm going to say that x is going to be equivalent to 2m plus n, and I'm also going to show that y is going to be equal to 2m minus n. All right, so I know that these values are different because one, you're adding n to 2m, and the other one, you're taking the difference of 2m minus n. So therefore, you're going to use two different variables for your substitution. Once I've done that, I'm going to go ahead and rewrite the expression as x squared minus y squared. All right, I don't know about you, but this looks a lot easier to me. Okay, so I'm going to go ahead and factor this difference of squares now. Factoring out the x squared minus y squared, I'll open up two sets of parentheses, and I know that the first term in each binomial needs to be the square root of x squared, which is x. I know that the second term needs to be the square root of y squared, which is y. And I know I need a positive and a negative, and if you've been keeping up with me, I'm an optimist, so I always put the plus sign first. All right, so put that plus sign first. From there, ladies and gentlemen, your difference of squares is factored. However, this is not the answer. X and Y is not a part of your original problem, so you can't stop right here. You must go ahead and put the value of X and the value of Y back into your answer. So that's exactly what I'm going to do. I know that my value of X is equivalent to 2m plus n. I'm going to add to that the value of y, which is 2m minus n. All right, so that's all the substitution for that first set of parentheses. Then plugging everything into the second set of parentheses, I'll have the quantity of my x value, which is 2m plus n, and then I'll have the opposite of my y value, which is going to be a negative 2m plus n. All right, so what happened with that value of y is I went ahead and I distributed that negative within there. All right, so notice that inside the parentheses I'm asked for the opposite of y. Well, the opposite of y means I need to change the signs and everything in my value of y. So I ended up with a negative 2m and a positive n for that last substitution. All right, so the next thing we want to do is simplify our results here. So that means that I'll have a quantity of 2m plus 2m, which is 4m, and look what happens to these ends. Well, they cancel out. They're additive inverses. All right, closing that set of parentheses off, I'm going to open up a new set of parentheses, and in the second set of parentheses, I have 2m and a negative 2m. Well, that cancels out. All right, so combining my n's together, n as in Nancy, I'll have n plus n, which is going to be 2n. All right, nice. Well, this is still not my answer because I can multiply this together. So let's go ahead and multiply that together. We'll have a result of 8mn, and that's the answer. Done. Box it. All right, that's problem number 5. Moving on to the next problem. In problem number 6, I have 6 times the quantity of x minus 1 squared plus 7y times the quantity of x minus 1 minus 3y squared. Ladies and gentlemen, this is going to be quadratic in nature, and it looks bulky the way it is right now. I don't like that x minus 1. So I'm going to assign in the variable c that will be equal to x minus 1. So I will be rewriting this as 6c squared plus 7yc minus 3y squared, like that. Okay? From here, ladies and gentlemen, I'm going to go ahead and factor this using the factoring process that I showed you in Factoring Quadratic Trinomials Part 2. I'll put a link right down there. All right? So I'll be multiplying 6 times 3 to get 18. So looking at the factors of 18, I'm looking for 2 factors that will subtract to give me 7. Well, that's going to be 9 and 2. So I'll open up 2 sets of parentheses here, and within those parentheses, I'll have my variable c, I'll also have my variable y, and I'll have my 2 factors, 9 and 2. I know that the 9 must be the sign of the middle term, so the 9 must be positive, and I also know that 2 needs to be negative because these 2 factors need to subtract to give me 7. From here, I'll be dividing both the 9 and the 2 by that leading coefficient of 6 and then simplifying. So I'll have 9 over 6 and I'll have 2 over 6, and then I'm going to simplify this. This gives me a result of c plus 3 halves y times c minus 1/3 y. All right, great. From here, any remaining denominators are going to go in front of my variable. So therefore, I'll have 2c plus 3y times 3c minus y. All right, so I have everything factored now. However, c is not a part of my original problem, so that means I'll need to replace this c with that value of x minus 1 that I replaced it with. All right, so let's move on. All right, so knowing that c is equivalent to x minus 1, we'll go ahead and plug that back into our problem. So I'll rewrite this using brackets showing that I have 2 times x minus 1 plus 3y times 3 times x minus 1 minus y. All right, so it looks just like that after plugging in that value of x minus 1 in for c. So then I need to distribute and simplify this as much as possible. So I'm going to get my arrows popping, all right? And that now gives me a result of 2x minus 2 plus 3y times 3x minus 3 minus y, and this is going to be our answer. It's at this point that I don't have any like terms that I can combine within the parentheses, so therefore I'm done. There's nothing else to do. And this is the result of problem number 6. Boxing it up. And on to problem number 7. All right, ladies and gentlemen, for problem number 7, I have m squared minus 4m plus 4 minus n squared plus 6n minus 9. At first glance, you may think that you do not need substitution in order to solve this problem, or that you could even use substitution for this problem. But check this out. I can rewrite this problem to look like so. I can show that this is going to be m squared minus 4m plus 4 minus the quantity of n squared minus 6n plus 9. So what we can do now is we can factor the first set of parentheses here. This is a perfect square trinomial, so this will end up giving us m minus 2 squared minus, factoring that second perfect square trinomial there, you'll have n minus 3 squared. All right. Now what you have before you is a difference of squares where you can once again use substitution. So I'll show that a is going to be equivalent to m minus 2, and I'll assign b to be equivalent to n minus 3. That allows us to rewrite this expression as a squared minus b squared. And then the factoring pattern for that difference of two squares will be a plus b times a minus b. All right, so now that you have it completely factored out, go ahead and replace that a with m minus 2 and your b with n minus 3. All right, let's see what that looks like. We'll have the quantity of m minus 2 plus n minus 3 times your a value, which is m minus 2, plus the opposite of your b value, which is going to be negative n plus 3. All right. Once you have this, go ahead and combine any like terms that you may find inside of the parentheses. All right, combining your like terms, you have an answer that reads m plus n minus 5 times m minus n plus 1, and that's going to be the answer to problem number 7. Let's go ahead and box it up. Just like that. All right, on to our last problem. For problem number 8, we have x minus 5 times the square root of x minus 24. We're definitely going to use substitution in this problem, and I want to show you that this could be rewritten in exponential notation as x minus 5x to the 1/2 power minus 24. I did that to show you that your first exponent here is going to be twice as much as your middle term's exponent, which means that it's quadratic in nature. So let's go ahead and say that our variable y that I'm assigning is going to be equivalent to the square root of x. That means I can go back and rewrite our original expression as y squared minus 5y minus 24. Once I have it rewritten like this, you'll see that it's just an easier form of your quadratic trinomials that you'll find. So let's go ahead and look for two factors of 24 that'll subtract to give us a value of 5. Knowing that our factors of 24 are 1 times 24, 2 times 12, 3 times 8, or 4 times 6, we'll be using 8 and 3. That'll give us a result that we're looking for. All right, so let's open up two sets of parentheses now. I'll have my variable y. I'll have the number 8 and 3, and remember that your largest factor is going to be the sign of the middle term. So that factor of 8 must be negative, and that factor of 3 will be positive, so that those two factors will subtract to get your negative 5 that you need. From here, we'll be plugging in our value of y again. Remember, that value of y doesn't exist. We made it up. We assigned the value of y to equal the square root of x, so plug it back in. You'll have the square root of x minus 8 times the square root of x plus 3, and this is the answer for our problem number 8. All right, let's go ahead and box this up. That does it for problem number 8. It's in a nice box for you. And once again, ladies and gentlemen, this was factoring using substitution from Mr. Witt and Fort Bend Tutoring. As always, please rate, comment, and subscribe. And if you're able, please donate, because that helps us bring you more free math tutorials from Fort Bend Tutoring. Peace.
Factoring. This includes topics such as GCF, that's the greatest common factor, like Obama, the difference of squares, quadratic trigonometry, oh Lord, that's when the pig is sick on all four sides, the sum of cubes, that sounds like one of them games they play, difference of cubes, oh that's just ignorant. AC method, yes honey, because you got to have your air conditioning in Texas. And factoring by grouping.